Hi everyone, in this video let's look at how to take a wireless packet capture if you have a Meraki access point. So specifically if you have Meraki managed access point, they introduced a feature called Intelligent Capture. So now over last 12 months, I think they have improved a lot. So now I will walk through the basic setup and then show how easy to take packet capture if you have a Meraki managed access point. So now firmware point of view, you need to have a 31 or higher releases, and specifically you have to have a Wi-Fi 6 or 6E, that is 6 GHz capable or latest Wi-Fi 7 capable access point to take packet captures. So now licensing point of view, if you have the Meraki Advantage or the enterprise, you can take on-demand packet capture. So now if you have the Advantage licensing, which is the highest premium end, so now you can take the proactive packet captures as well. You can schedule packet captures to be taken on an event base, event triggered base. You can take the proactive captures, so you don't want to schedule it. Now feature point of view, it is very easy. You go to the assurance from your dashboard and then you will see the intelligent capture setup there. Now before go and demonstrate this, let's look at how this particular packet capture process being working, because in a recent Cisco live presentation, Cisco has bit more given technical detail how behind the scene this is being done. So it is important to understand, because not a lot of vendors giving this level of capability. In that way, let's try to understand how this particular packet capture process in a Cisco access point Meraki. Now this particular slide I have taken from a Cisco live presentation. I have given the reference here as well, so you can go and watch this presentation. So now so now what they have done is basically they have a completely proactive PCAP kind of process. So they are trying to getting packets. This is basically your Wi-Fi chipset point of view. They are getting a mirror of those packets to their PCAP process. So why? Because sometimes your Wi-Fi chipset may give a certain capability of packet capture, but they may not have a good a ring buffer. They may not able to in the large scale environment, if you are trying to capture traffic directly from the chip, sometime it can drop packets, introducing little of other challenges. In that way, what Cisco has done is they simply getting a copy of the entire traffic from the chipset point of view, and they analyze those packets in their PCAP analysis kind of process. Now in here, they will get a data packet flow. You can see here, directly from their traffic directly get here, and then sometime packet will be reordered. Why? Because sometime in the normal processing point of view, packet being processed, with certain sort of a rearrangement. So now what they are doing is, once they get into their PCAP process, so they're basically reordering the way really it's supposed to be. So in that way, now they have a full-fledged packet processing engine without impacting the client servicing. They can give you a full packet capture capability without impacting your live client servicing capability. So that's the big advantage. And then you are not limited by the memory of CPU of your Wi-Fi chipset. They have allocated additional resources. They can do a high-end kind of packet processing engine. So then you can capture multiple client traffic without affecting the live client servicing capability. In that way, that's the advantage. In that way, this is really in the enterprise environment. You have to have some kind of large scale capability, because we are talking about a lot of client. In that way, whatever you taking packet capture here should not hinder the wireless access point performance. In that way, the takeaway is we are basically getting a copy of your traffic from your Wi-Fi chipset, and the data flow point of view, we are getting the data flow traffic from there, and then we basically rearranging within a Cisco packet capture kind of process point of view. So now what we'll do is we'll take a simple packet capture. Now let me show my Meraki setup. So now in here, let me just minimize this. And this is my Meraki setup here. Now I have a Cisco 9178 access point. So now, you know, like, you can see, you know, like, if I go to the detail, I have enabled SSID, few SSIDs, MRK-P, like a PSK SSID, MRK-X.1X SSID, mainly across these two bands, 5 GHz and 6 GHz. So channel number 52 and 21. So now what I'm going to do is connecting a client for this SSID and take a packet capture. So now, as I said in the assurance, if you go to the intelligent capture, now you can, you know, like, you have a different options, you know, like schedule captures, proactive PCAP enablement. So now at this particular stage, I will basically show you, you know, like how to say simply take a schedule packet capture. So now you can select, you know, like with the all access point. In my case, I have a 9178 only one access point. I only want to take packet capture from that access point. So now output, I will save it to download. That means I'm not saving in my Meraki cloud. So time wise, I think maximum you can go for 10 minutes. Will basically go for like a 120 second. That should be good enough. If you want, you can apply certain capture filters. In here, if you view example, you will see different filter options. You can set it up. But we will capture everything, you know, like, just to see. And let's basically give this like a Meraki PCAP Wi-Fi 7 or something like that, because I have a Wi-Fi 7 capability. So now you simply say start capture. Okay, if you give us some notes here, basically you can give some additional context why you are taking this packet capture. In this example, I will not add additional notes. I simply say now packet capture being started. So now let me go to my client devices. So now I have a Windows client environment. So at the moment, this is not connected to any SSID. So I'm going to here and say just connecting to the Meraki -P, which is a personal SSID, which should have a Wi-Fi 7 capability. So NetSH WLAN show interfaces. Now you can see my client connected to across two different band Wi-Fi 7 connectivity, 11BE. So now I have a Wi-Fi, you know, like .1x SSID as well. So let's basically connect to .1x Meraki-X and make sure let's give my credential. Let's say now say connect. Now it is connected using .1x. You can see MRK-X. Still it is a multi-band SSID. So AKM value 5, WPA3 enterprise. So now latest Windows operating system supporting multi-link operation across .1x SSID as well. So now in here, you know, like it's packet being captured. So once the 120 second interval expired, it give me option to download the packet. So now let's have a quick look whether we can see all those details being captured in our packet capture. So now this is the Meraki-PCAP. So now if I want to see client association, I will go to management and association request kind of frame. So you can see I have two association. So let me filter the first one, which is the personal SSID. I will copy this MAC address value and go and put into the client filter. That's the way we are analyzing traffic here. Now you can see here a client go through SAE kind of authentication and associated request response and four-way handshake. So certain packet being captured twice, message 2 and message 4. So now you can see now the inner detail. This is the important part. You can see the traffic being give you as a decrypted view. Why? Because now this is capturing from the Meraki access point. So now you have all the encryption keys. So then AP can give you a decrypted view. So we can see client got a different IP addresses, like DHCP protocol point of view. This is the IP address client has got 232.115. So then if you check the earlier IP address detail, it should match. So that's the one advantage in the Meraki, you can get the decrypted view, quite useful when you're troubleshooting, if you're going through what client is doing, you can get a decrypted view. So specifically in the .1x scenario, if you enable WPA3, if you're taking over the packet capture, you are not able to decrypt in the traffic. Now taking packet capture from the AP side, you should be able to get the decrypted view. Now in here you can see client association point of view. They may be associated using 6 GHz. If you look at the client association here, association request frame, you will see all the detail. He is basically requesting to connecting using a particular AKM value, which is WPA3 personal, AKM value 24, which is Wi-Fi 7 certification point of view. This is mandatory using GCMP 256, AKM value 24. Now in here, multi-link operation element is there. That's indicating client like to have a multi-link operation. Now let's quickly look at the .1x association as well. Whether it is you can see all the detail and whether you can see a decrypted view as well. So again, you can go to here and copy the client MAC address. So that's the client MAC address being used. Now if I put the client MAC filter, so you should this time able to see .1x kind of process. Now initially this is our personal SSID association Meraki, because it uses the same MAC address. Now if you subsequently you can scroll through and you can see here sometime I disassociated, disconnected from the personal SSID, and they go through the .1x kind of association, which is 2 authentication frame, as in request response, and EAP frames. Client basically trying to do TLS or AP requesting to do TLS, then client basically negatively acknowledging, and then go through the PEAP process. And then they exchange in the certificate, and then EAP success message come. Client will go through the 4-way handshake, and then you will basically getting your full address of the full frame flow. Now even here you can see the decrypted traffic flow. We are doing a .1x, but it is giving me all the DHCP, ARP, DNS, all of this kind of. That's the power of, if you're taking packet captures from the cloud environment, you can see in here I have filtered out control frame, but if I remove this filter, you should see all the control frame included, you can see acknowledgement, block acknowledgement, data frame. That's the power of, doing packet capture on the APN. You will get the full packet flow, and even the data frame, you will get the decrypted fashion. Okay. In that way, that's a sort of a quick high level, how easy to take packet captures in the Meraki environment. And now in a separate post, so now what we'll look at is, now we basically took the packet capture, using Meraki being servicing the client. Now the advantage is in here. So now because we can use Meraki access point, it can, if you're using a Meraki access tool to packet capture, so we will basically get a copy of everything go, like whatever heard by the Meraki access point. So if you really want to, Meraki access point, not purely as a sniffer mode. So what we are going to do next, I will servicing client using a 9800 manage access point, but I will set my Meraki EAP to those channel numbers and then let it take a packet capture. Okay. In that way, now idea is, so we are not basically getting packet captures from the client servicing kind of Meraki access point, but we are basically setting those access point into channel where you want to capture and then take a packet capture. So in that way, still we should be able to get the packets, but only difference is traffic will be not decrypted. Why? Because now this is not servicing the client in that particular sense. I am setting those Meraki AP into a channel numbers service from a different vendor or different environment. Okay, so this is effectively like a sniffer mode, but not technically sniffer mode supported there, but we are setting channel numbers like that. So we'll do it as a separate video because I don't want this video to be go so long. We'll do it as a separate video. Okay, until that, take care and study wireless.